Hi, I'm Jason Larsen, Technical Business Development Manager for Radwell International. Today we're kicking off a series of videos we're calling how-to videos. It's a series of videos that are going to be more in depth than what we would normally shoot. It's going to be a series of videos on how to repair a circuit board, how to CNC machine a part, how to repair an electric motor shaft or troubleshoot a VFD. Today's video is going to be on how to repair a burned up circuit board. A lot of the times when you're out in the field, you'll come across the board, you'll take it out of a machine, only to find out you have a burn mark on the board from a failed component or a failed trace. We're going to take you through the in-depth steps on how to do a repair start to finish. Come on, let's go head over to the bench. All right, so this is our victim here for the day, an old DC drive. Came into us for repair that was burned up. And before we get into anything, let's talk a little bit about safety. So when you're doing a repair like this, we're going to be running into a few safety issues. One of them is going to be a breathing hazard. We want to make sure that we're wearing a dust mask when we're doing any grinding of old burned up circuit boards. The other thing we want to be safe also is with ESD straps. We don't want to cause any additional damage to the boards as we're working on them. So we'll just get into it, and we'll show you the damage on this board. All right, so we're just going to pop the gate wires off of here. One of the things to just keep in mind is that these are like what they call like a fast-on connector. You want to grab them by the connector itself and not by the wire. Just give them a gentle tug and they'll pop right off of there. And as I'm doing the disassembly on this, I just want to have you keep in mind that this type of repair is always a compromise. Obviously, the best thing that you want to do is to replace the board, but sometimes that's not an option. As equipment ages, manufacturers don't support these parts any longer and can't get the boards anymore, so we're forced to do this type of repair. But obviously, the first choice is always to replace the bad board if it's damaged this bad. But I've been doing this type of repair for years, and I've always had them last a very long time if they're done correctly. Also, one of the things that you should make sure that you do, if you're not familiar enough with the equipment, first thing you always do is take photos. That way you can remember how it goes back together in the end. Pop this wire off of here. Now this board's free for us, and we will get to see the damage. I think this one's going to be good. Oh yeah, look at that. That's a good one. We're just going to pop these wires off here. Just make sure that they're marked so you know where they go back at the end of the repair. Or, like I said before, make sure you take photos. Photos are your friend. Always good to refer back to. And we got two more wires coming off the transformer down here. Just pop this whole board loose. So notice as I'm doing the desoldering of these wires, I'm adding some solder to it before I pull the wire out. I found that kind of refreshing that solder connection, adding some flux to it, the solder's got flux in the core, makes your whole life a whole lot easier trying to pull this stuff apart. Makes the solder flow a lot better. Now we'll get a good look at this guy here. Put this off to the side. right, now the first thing that we need to do is, obviously, like I said before, take photos of the damage, make sure you know what you're working with. The other thing is, try, before you start doing any cleaning of the board, identify what's been damaged and what needs to be replaced in addition to board repair. So we can see on this drive that we have 3 identical circuits, which is great because otherwise I would have never been able to identify this resistor and this capacitor value. Good thing is that we've done previous repairs on these and we have all of this information written down. But if we didn't have that information, I would be looking at the duplicate circuits to be able to recreate that circuit on this leg. Okay, so we're just going to get some of this stuff out of the way before we start cleaning. And as I'm clipping this off, I'm leaving a little bit of a leg coming out of the board. That way I have something to grab onto. If I were to use a pair of flush cutters, cut this down flush to the board, when I go to disassemble, when I go to take the leads out of the board, I wouldn't have anything to grab onto. So this MOV doesn't look like it's bad, but we're going to replace it regardless. So we'll get this guy out of the way too. All right, now that that's all out of the way, we're going to do some basic cleaning, get all of this black soot off the board, and take it from there. All right, so we're just going to clean this board up. Any cleaning solution that doesn't leave a residue is generally considered okay because we're going to do an additional cleaning later on down the road. We tend to use a couple different products here. Use this flux remover from Microcare. This is pretty good. We also tend to use a lot of this electro wash from Chemtronics, but if you're out in the field and you're doing a repair, isopropyl alcohol will do. You do have to be careful with other cleaning supplies like acetone. We tend to use these pre-saturated acetone wipes. They do work very, very good on cleaning, but they will take off inks and things like that. So you got to be careful that you don't remove your part numbers off of your components with the acetone. But isopropyl alcohol, glass cleaner will work, things like that. And we just have a little piece of pig mat down here just to soak up the excess cleaning supplies. Always want to keep your bench sanitary. Looks 10 times better already. Doesn't look that bad. Okay, that'll be good for now. All right, so this is the problem right here. So we got a lamp that's obviously burnt up. But this area of the board right here, where you can see the fiberglass is damaged and burned. You got to get that all out because it becomes conductive and can cause a short in the future. So you got to get all of this burnt board material out. So now we'll go and we'll start removing our legs, our leads. So a good technique is to come down here, pair of pliers, pull it up through. I've seen this done a million different ways. This is just my technique. There's no wrong way to do it. One of the things you got to be careful is that when they're manufacturing the boards, if they put the leads down through the boards and bend them over at a 90, when you start yanking them through, they could damage the pads. So you just want to be mindful of that. Don't tug and pull on it. Another thing is some people like to use solder wick. Some people use fancy pneumatic solder pumps and things like that. I like to use this very basic Soldapult, S-O-L-D-A-P-U-L-L-T. Been using these for many, many years. They're cheap and effective and last quite a long time. Okay, so we're just going to clear the solder from these pads here. So I always put a little additional solder on each one just to freshen up the joint. Get some fresh flux on there. And super duper tip of the day, with these guys, sometimes what will happen is as you're soldering, the solder flakes will end up on the inside of this guy and will end up falling out onto your board. So you come in here, you heat your joint up, suck your solder out, and then flakes will end up falling out onto your board. But the super duper tip of the day is to get some white spray lithium grease and coat the inside with this. It does two things. It not only increases the speed of the retraction, increasing your vacuum, but it also will hold on to those solder flakes so they don't fall back out onto your board. See, like that. See that? That'll fall out onto your board, cause a short later on down the road. So I'm just visually inspecting that I got the solder out of each one of these holes. It looks like they're all good, but obviously these ones down here are in bad condition, but we're gonna fix that. Another good tip is to, before you start and you take your photos, print out your photos, have them on the bench beside you, and make a drawing of where your traces should go. Okay, so you can see this particular pad is just damaged. We're going to replace that anyways. So before we start doing any burned board extraction, you can see from this circuit here that this pad goes over to this screw. These two guys can connect together, and then this guy's obviously okay. So what we're going to do is we're going to Dremel out all of that damaged board area. So what I like to do is tape off the area so I don't accidentally nick the board and cause more work for myself and have to do more trace repairs than I have to. And this will kind of define the area of the repair. So just because a board is dark in a particular area doesn't necessarily mean that we have to Dremel or grind all of that material out. You don't want to do that. We're going to do further cleaning on this. What we want to get out is all of the material that is soft and will flake away and is conductive. Make sure you keep good track of all your hardware, obviously. Some of this stuff can be hard to find, but we have a lot of this stuff in stock. If you ever need us, give us a call. Not only do we do repairs, but we sell a lot of parts too and supply other repair houses and customers with all kinds of cool stuff. So this just kind of defines our area that we're working on. And anything that feels soft or is going to chip away, like this right here, see that's flaking away right there? We got to get all that out. That is a recipe for disaster later on down the road. Yeah, so I'm going to take a stainless steel wire brush and just clean up some of the, just lightly clean off some of this extra burned material. So you can see here we have obviously a bad trace, burnt material that we got to get out of there. So a couple things on the Dremel. I tend to like to use carbide burrs. If you end up using an abrasive stone, they will get clogged up. But if you use a carbide burr or an end mill, they will last longer, but they will wear out and get dull. Small carbide burrs work really, really well, but you have to be careful if you use something with a open flute design, like let's just say a 3-flute end mill that was designed for aluminum. These are extremely effective, but they can get away from you very, very easily. So you got to keep a good grip on this. That's another reason for the tape, is to try and keep you from nicking the board or any other traces. Now that we're done dremeling out the hole in the board, don't judge me on my squareness of my hole, but it's there, it's done. I'm just going to clean up a little bit more of this burn marks here before we move forward. And I just did want to make mention again that obviously this type of repair is always a compromise. It's never the first choice, but sometimes you got to do what you got to do to get the machinery back up and running. I'm going to take, got a variety of razor blades and scrapers here that we'll use to get some of this extra stuff off the board. And before it's complete, we will fully detail everything. But we want to get this off here. That's close to the damaged area. What we're using here is just more of that flux remover. Just get off any of this extra black stuff that's right around the damaged area. Looking pretty good. Get one of our acetone wipes. Again, a lot of these just general cleaning supplies will do the trick, but acetone does a good job. But again, it'll eat the ink off of a lot of stuff, so you just got to be careful. But we want to get any of the oils off, any of the burn marks, any of the leftover stuff. So you can see here, this is dark area, but it's not soft. It's not through the board. That won't cause any problems going down the road. Yeah, see, that's solid. It's just a little dark. That should be okay. Okay, so we'll leave it there. The next step in the process is to re-tape off our area so we can fill that hole. So when you're doing this, you want to obviously do a good job. You always want to have good workmanship like practices. You want to tape off just outside the repair boundary. Actually, we're going to do this. We're going to tape this from the backside fully. You're going to want to press this in hard. You don't want the epoxy to seep outside the boundary area. Clean this up here. And we're going to do our pour from the front side. So we're going to want to leave, I guess, about 1/8 of an inch on the other side of good material that the epoxy can bond to. And this is just regular old painter's tape. You can use whatever you have on hand. This is just help clean it up later on. And obviously, if you're in an emergency situation, you don't have to have this, but we're in the shop today, so obviously we can take the time and do a good job. Okay, just press that in hard. Give it a good seal. All right, just give me a second. I'll find something to prop this up so it's level. Yep, that'll work. Okay, so the epoxy that we're going to use today is a brand called Marine Tex. You can generally use a wide variety of epoxies. We've used clear stuff, we've used all kinds of different stuff, but generally speaking, you want to find an epoxy that's not conductive and will be pretty hard and durable. But we found this to be pretty good. Stands up over the years, you can drill it, you can tap it. You want to mix this about 50-50. Now while I'm mixing this, I'll just give you some general epoxy tips, is that if at all available, you want to try and not use a paper container. Use a plastic one if you have it. The paper can actually absorb some of the resins out of the epoxy and cause your mix to go south. So use plastic if at all possible. It won't absorb anything. And then obviously try not to whip up any air bubbles into the mix. It'll just end up causing you more issues later on down the road. Just take your time, make sure it's thoroughly mixed. We have a 5-minute set time on this epoxy, but a 24-hour cure time. So what that means, in 5 minutes, this will no longer be good, but will not be fully ready to use for 24 hours. But I found most instances, 12 to 18 hours will be okay. See afternoon time today, so when we come in tomorrow morning, it'll be ready to go. So that's pretty good. You're going to want to get this into the hole as soon as possible. That way it has a chance to flow down in through all the edges. Working into the corners, make sure it gets in everywhere, make sure there's no air bubbles. And you kind of want to overfill this just a little bit. I've also found these to be pretty handy too. These are just plastic razor blades. You can use to smooth it off, just like that. Don't worry about getting on the tape, that's what it's there for. Kind of like doing drywall or spackling, right? Just fill it in. All right, so we're going to let that sit for just a couple minutes, not till it's fully hard, but 50% of the way. We'll leave it sit for 2 or 3 minutes and come back, and before it's fully cured, we'll peel off that tape. If we wait till the end, till it's fully cured, and we go to peel off that tape, this may crack and peel off the epoxy out of the joint. So as of right now, we'll come back in a couple minutes. Okay, so you can see the air bubbles actually rising to the top in the epoxy, and you can see now it's not fully set, but it's not running anywhere just yet. Meaning, if we peel that tape off, the epoxy's not going anywhere, but it's not hard yet. So this is what I wanted to show you, the air bubbles. If you get that in your epoxy, that's going to be a failure later. So try to avoid that. We're going to try and peel the tape away from the joint. And we want to leave the backside on until it's fully cured. We just need to get the epoxy off the front side. So I'm sure, as you guys can tell, that tape on the backside is acting like a dam and is going to hold that epoxy there until it's fully cured. So see, we're starting to get a little bit of peel right there. I should have got this about a minute sooner, but we can kind of score that just like that, just so it's nice and neat. If we had waited, that may end up being a potential fail point in the future where this would come up. That's it. Just kind of make sure everything's good. Yeah, okay, so it looks good. We'll let it cure overnight and we'll see you in the morning. So now it's the following day. The epoxy's had a chance to cure overnight. You can see it's nice and hard. So we'll go ahead and we'll take off our backing tape here that we used as a dam. Perfect. Looks great. You can see it's nice and solid. So now we have to prep the board in order for our new components. So we have this lamp here that needs to go there, resistor, capacitor. Get this guy back together. So because we use that particular epoxy, that MarineTex brand epoxy, we'll just have to go and drill a hole right through it. So before I do that, I'm going to use this drill bit as a location. It should be good right there. All right, so the first component that we're going to put in is this lamp. So obviously the lead was burned up that went from this pad over into here. We're going to put the guy through the hole there. Bend it over at a 90 so it stays put. And for right now, just going to solder the one leg in. And before I solder the second leg in, I'm going to go ahead and do a quick repair. So I purposely left this little tab on the edge here. Scratch off this extra material over top. And we'll tin it. We're going to take and grab that lead that we had cut off from the other side. I'm going to tack it to here for now, just like that. We're going to come back and give this a little bit of reinforcement after we're done. And we're going to pull this down through the same hole. Just like that. So now I like to make sure that all of my leads are bent over at the same angle just to make it all look nice and neat when it's done before I solder them in. And I always just like to come to the top side and make sure we got good solder penetration all the way through the via. Sometimes I'll touch them up on the top side up here. Okay, it looks pretty good. Now, the last step in the process is to obviously clean off your flux. And one of the things that we're going to do too is we're going to reinforce the bottom side of this bulb here. You can see as it goes through the hole that it's a little loose. We don't want that breaking over time. This is going into a machine. It's probably going to have some vibration to it. So we're going to go ahead and we're going to just reinforce this bulb. Put a little bit of adhesive on the bottom side down here. Alright, so what I got here is just a little bit of CA glue, cyanoacrylate, or otherwise known as garden variety super glue. So we'll just put a little dab on here. And if you guys have not used this super glue accelerator, it's been a game changer for me and us here, because even though they say super glue is, you know, instant, we all know it's really not instant. But with this super glue activator, it really is instant. So we'll get this out of the way here, and I think we're just going to clean up the bench a little bit, and we'll come back for some final thoughts. Yeah, so as you can see now, we got the board completely back together. We got all of our components soldered in there, and the unit's just about ready to be reassembled. I'm just going to go back through, clean up a little bit of this flux just to make it look a little bit more professional, and put it back together. But you know, as I said before, guys, this is always a compromise. It's never the first or the best repair method, but sometimes you have to do what you have to do to get the machine back up and running and into service. But as you can see, in the end, the damage really wasn't all that bad. If you look, you know, remember back to where we started, this whole area was all blackened just because of these components were burned up. But the actual damaged area was literally very small. But you know, we've seen over the years a lot when, you know, IGBTs and big MOSFETs and things like that blow up. You might have a very large area that's burnt up, you know, inch square, 2 inches squared, something like that, where you'll have to go in, and this method may not apply. It's just too large of an area to fill in with epoxy, and you might have to graft in a piece of fiberglass and do a whole lot of trace repair. But this is an easy repair that I think most people can probably do, and more than likely out there in the field, you know, in the workshop, things like that. But obviously any of these pieces and parts we sell. Obviously we do repairs here. We sell a lot of the testing equipment and soldering irons and all that stuff. So, but if you guys have any questions, feel free to reach out to me directly. My email is jlarsen, JLARSEN, at radwell.com, or you can call me directly if you'd like. It's 1-800-332-4336, and I'm at extension 578. I can be reached anytime. A lot of times that number is forwarded over to my cell phone. But we'll also post my contact details directly in the link in the video description. But here we are. For more information, visit us on the web at radwell.com or connect with us on social media. Thanks for taking the time to watch our video today. We really appreciate it.